It's a new era. The giant leap in sensitivity, especially in the infrared, is like upgrading from Galileo's telescope to a modern telescope overnight, Maialino concluded. Before the JWST came online, I thought maybe the universe isn't so interesting when you go beyond what we could see with the Hubble Space Telescope. But that hasn't been the case at all. The universe has been quite generous in what it's showing us, and this is just the beginning.
In particular, they are aiming to discover small black hole seeds in the infancy of the cosmos and put to bed the debates surrounding the premature growth of supermassive black holes. As well as learning more about this black hole and its galaxy, the team behind this research believes that the power of the JWST should help uncover more black holes in the early universe.
Ultrafast winds of particles belched out from around the feeding black hole are likely to be pushing away gas and dust from the galaxy's heart. Cold clouds of gas and dust collapse to birth stars, so this means that the black hole is grinding stellar birth to a halt, in the process, killing the growth of this small galaxy.
The team estimated that if this period of voracious feeding for this black hole had been proceeding for 100 million years, it might not have had to start life as a heavy black hole seed. This newly discovered black hole is accreting matter from its host galaxy at a rate 5 times higher than the Eddington limit.
While black holes don't emit light because they are bounded by a light-trapping boundary called an event horizon, their massive gravitational influence does cause the material that swirls around them to be violently churned and heated, emitting radiation in the process.
A mathematical formula known as the Eddington limit marks how fast a body, like a star, can accumulate mass without the radiation it emits, its luminosity, pushing that mass away and thus cutting off that food supply.
Yet, on the flip side of this, the rate at which the black hole in GNZ 11 is accreting matter could suggest that black holes may be capable of feeding much faster than other black holes discovered in the early universe have been observed to do so. Scientists currently have 2 main routes that black holes could take to reach supermassive status in the early universe.
It's like seeing a family walking down the street, and they have 2 6-foot teenagers, but they also have with them a 6-foot-tall toddler, Maynooth University research fellow John Reagan.
The size of early supermassive black holes that formed when the universe was less than 1 billion years old is a problem for formation theories because reaching a mass of millions or billions of times that of the Sun should take billions of years of constant feeding.
It's very early in the universe to see a black hole this massive, so we've got to consider other ways they might form, Maialino said in the statement. The ravenous black hole that existed just 400 million years after the Big Bang could help explain how supermassive black holes grew so rapidly.